Hi all, welcome to another video of electrical machine design based on KTU syllabus. So today we are going to discuss a design problem from DC machine module. So the question here is, determine the main dimensions, number of poles and the length of air gap of a 600 kilowatt 500 volt 900 rpm DC generator. Assume average gap density as average gap density means that is BAV, which means it is the specific magnetic loading. So it is given as 0.6 Weber per meter square and ambient conductors per meter, that is AC. The specific electric loading is given as 35,000. The ratio of pole arc to pole pitch is 0.75 and the efficiency is 91%. The following are the design constraints. VA, that is peripheral speed should not be greater than 40 meter per second. The frequency of flux reversal should not be greater than 550 Hz. Current per brush arm should not be greater than 400 ampere and armature MMF per pole should not be greater than 7500 ampere. The MMF required for air gap is 50% of armature MMF and kg, that is gap conduction factor, is given as 1.15. So these are the given values. So based on the given data, we have to design the main dimensions, number of poles and length of air gap. So first we can design the main dimensions. So we know that always for designing the main dimensions we have to start from our power divided by the armature equation, PA equation, that is C0d square lns, that we know. So for that we have to find the output coefficient C0 first. So C0 equation is pi square BAV is into 10 ratio minus 3. So both BAV and AC are given. So we will get C0 as 207. And after that the power divided by the armature, that is PA. Here it is a DC generator. So the PA will be equal to output by efficiency. So 600 by 0.91. So we will get 660 kilowatt. And small n, that is speed in RPS, is given as speed in RPM by 60. So 900 by 60, it is 15 RPS. And we know that equation is PA is equal to C0 d square ln. So from that we can find d square l as PA by C0 into n. That is PA by C0 into n is equal to, after solving we will get it as d square l as 0.2126 meter cube. Then we have to separate the value of D and L. For that one value is given, that is pole arc to pole pitch is given, that is the value of psi is given. Actually the psi will be equal to L by tau if it is a square pole phase machine, but it is not given. But here we can assume it as a square pole phase machine and we can take the psi value as L by tau. Okay, and for writing that L by tau value also, we know that the equation for tau is, okay, that is equation for tau is pi d by p. So for that we must know the value of number of poles. Okay, so next we are going to find the number of poles first. So number of poles can be found using some steps. That is, the first step is the frequency of flux reversal should be in between this 25 and 50, that we know. For a DC machine, frequency of flux reversal should be between 25 and 50. So here the F is equal to P into N by 2, this is the equation, and we are finding the value of frequency for different values of P. That is, if we are selecting the value of P as 2, we will get F as 15 Hz. It is not in between 25 and 50, so we can eliminate that. And if you are selecting P is equal to 4, you will get 30 Hz. For P is equal to 6, we are getting 45, and P is equal to 8, we are getting 60. So from these values we know that in between 25 and 50 we are having two values, that is for P is equal to 4 and P is equal to 6. The frequency range is between 25 and 50. So both the value of P is equal to 4 and P is equal to 6 are acceptable. But we have to check for another condition also, that is current per brush arm we have to consider. That is, for a machine we know that the current per brush arm should not be greater than 400 ampere. Okay, and the current per parallel path should not be greater than 200 ampere. That we have to check here. So for that, first we have to find the current equation, that is IA. We know that current equation is, that is P is equal to E into IA into 10 raised to minus 3. Okay, that we know. And here we must obtain the value of current in ampere. So we are using, that is IA is equal to, that is 600 into 1000, that is 600 into 10 raised to minus 3. Okay, divided by V. V is given as 500 volt. Okay, V is given as 500 volt, 600 kW. Okay, so 600 kW by 500. So we will get IA as 1200 ampere, and we are going to find the current per brush arm. Okay, current per brush arm. So here current per brush arm, the equation is 2IA by P. So here the number of poles, if you are selecting the number of poles is equal to 4, we will get IB as 2 into 1200 by 4, so it is 600 ampere. And for P is equal to 6, we are getting IB as 2 into 1200 by 6, so it is 400 ampere. So the second condition is within the allowable limit, that is current per brush up should not be greater than 400 ampere. So we can adopt the value of P is equal to 6. Okay, that is IB is limited to 400 ampere, so we can't choose P is equal to 4. So here we are choosing P is equal to 6. And after that we have to find the main dimension, that is we know that L by tau, that is psi value is 0.75. That is here we are assuming that it is a square pole phase machine, that's why L by tau is 0.75, and L is equal to 0.75 into tau is pi d by P. Tau is pi d by P. So here P is equal to 6, so pi d by 6, and we will get L is equal to 0.393 d. And by substituting these values in d square L equation, that is in d square L we are substituting instead of this value L, we will get 0.393 d cube as equal to 0.2126. From that we will obtain d is equal to 0.815 meter, and after substituting the value of d here, we will obtain L as 0.33 meter. Okay, so these are the main dimensions, and next we have to check whether these values are correct or not. That is, some constraints, some design constraints are given in the question itself, that is VA should not be greater than 40, and something that is armature MF per volt should not be greater than 7500 ampere, like that. So we have to check for that also, then only we can finalize the design whether it is correct or not. Okay, so we know that VA, first we are checking for VA. The equation for peripheral speed VA is equal to pi d ns, pi d into n. Here we are choosing the value of d as 0.815, and small n we know it is 15. So here we are obtaining the value of peripheral speed as 38.38 meter per second, and it is within the limit, that is VA should not be greater than, as per the question, VA should not be greater than 40, but here it is only 38.38, so it is correct, it is within the limit. And next we are checking for armature M of 8TA, that is we know that its equation is AC tau by 2, that we know AC is given, and tau is given as pi d by P. Here the value of P is 6 and D is 0.815, so we are substituting that values here, and we will obtain AT as 7350 ampere, and it is also within the allowable limit, that is here it is given that armature MF per pole should not be greater than 7500 ampere. So the given value, okay, that is it is also in the allowable limit, so the D and L, okay, it is the better choice for this design. And next we have to find the length of air gap also, it is also mentioned in the question. So for that the equation is, and it is given that in the question it is given that the MMF required for air gap is 50% of armature MMF. Okay, so here the ATG, that is here, if you are writing the equation for LG, the MMF required for air gap is 50% of armature MMF, so that we are writing 0.5 here. If it is given as MMF required for air gap is 70% of armature MMF, then we have to write 0.7 here. Okay, but here it is 0.5, and the equation for LG is 0.5 AC tau by 1.6 into 10 raised to 6 into kg bg. So here AC we know, tau we can find, tau we know, and kg it is given as 1.15, bg we don't know the value of bg, but we can find the value of bg as using the equation, that is maximum flux density bg is equal to BAV by psi. Okay, that is psi is equal to BAV by bg, that we know, that equation we know. Okay, so from that we can find bg as BAV by psi. So we will get the value of bg is 0.8 Weber per meter square, and the value of lg, by substituting all the values we will get lg is 0. That is 5 millimeter. Lg is equal to 5 millimeter. So I hope all of you understand the problem well. So thank you.